Are we on?
Yes, it's working.
All right. Thank you. Well, welcome everyone. This is the Accelerate Quality Validating Your FHIR Implementation Guide session. My name is Richard Ettema, and I am a lead architect for the Touchstone project here at aegis.net in the US. HL7 FHIR proficient for quite a while. My background is 37 plus years in the industry, 17 in health IT development implementation efforts, and the last 7 or so years, I've been a contributor to the FHIR specification with a focus on testing. So senior architect, lead developer for Touchstone. I'm also the author of our Aegis Wildfire Public Test Server and Client. So what we're going to be doing today is going over FHIR implementation guides with a focus on validation. Because when you look at a FHIR implementation guide, it's all about ensuring that what you're building is going to then be validated in terms of functionality and data. We also need to be able to publish those implementation guides. So I'm going to be kind of brave today and actually do a couple of live demos. One of them is a publication process that we'll take a look at. And then we're going to get into a little bit of a discussion about testing and certification, because that's what the implementation guides are all about. So we want to see how that support is defined within the implementation guide, and then take a scenario from an implementation guide to a test definition or test script, as they're called in the FHIR specification. And then finally, we can actually see an example of this in the Touchstone testing platform as an example of how you would execute that test definition and see the evaluation. So that's going to be my other live demo. So first of all, a FHIR implementation guide, this is a resource type within the FHIR specification, but essentially what it means is a set of rules about how FHIR resources are used or should be used to solve a particular problem. The important part is that the implementation guide, when it's generated, when it's published, produces associated documentation. So there's a lot of information that comes along with it. So the implementation guide as a resource type is how we logically think of defining what those component pieces are for the ultimate HTML representation of that guide. So the contents then are a set of logical statements that represent those conformance requirements. So as an implementer, these are the things that you're going to be following. So whether it's FHIR profiles or narrative context, whatever it might be. And it's also rather important that we have a lot of examples that are included which illustrate how to use those profiles, how those different operations or scenarios might work or be defined within the implementation guide. So let's talk about validation for a little bit. Validation testing for conformance to a FHIR IG implementation guide involves verifying the proper behavior based on the IG narrative. As I said, there's going to be a lot of content in the implementation guide when it gets generated. So guidelines, use cases, scenarios, and security requirements are just some of those. Very, very important. Read that documentation carefully to understand those different scenarios. A lot of what goes into the implementation guide are those conformance artifacts, which we'll talk about in a minute in a little bit more detail. But the idea is that there's this validation engine that comes with the base specification. And that's the Java RI validation engine, as I've noted here. So this is maintained by the FHIR community, most notably Graham Grieve, James Agnew, and other members of the community. There's a .NET version of the validation engine that is available as NuGet packages. So Ewout Kramer with FHIR Brian Postwaite out in Australia, and again, a lot of support from the community to maintain these implementations. But those validation engines are going to take those conformance artifacts and use them to validate your data. So those resource instances that you're going to have. And we'll actually see how that works a little bit later on. So first of all, the narrative. Again, use cases, scenarios, security requirements, and so forth. We're going to take these definitions and we're going to use them to define test definitions. because ultimately what we want to make sure of when we have our implementation guide is that we can use that implementation guide in a testing scenario to make sure that simple tests for individual operations are working correctly. So being able to do a search operation with the correct parameters and so forth. We can also take those use cases or scenarios and build complex workflow patterns, if you will, for testing multiple operations. Then within the testing environment, we're going to have a lot of different assertions or asserts, as we call them, to verify conformance to the FHIR specification, as well as, of course, the implementation guide constraints. So we're going to leverage those conformance artifacts in this regard. The asserts will also verify specific IG requirements. So when you think about building a test definition, it's not just simply invoking the validation engine, although that's a big part of it, but it's also taking a look at those use cases and scenarios and teasing out what those workflow patterns might be, how things should behave, even down at the data level. So the way that we do that is through the use of a test script. So as I said, in FHIR, there's this resource type called TestScript that's been around for quite a while now. And we leverage that in a FHIR test engine. And that's all defined, again, as part of the specification. So if you're going to be building a FHIR test engine, there it is right in the spec for you, where you can go examine that. The TestScript resource is also there as a first-class resource type, and so that is your definition of how you want the test to execute and how you want to apply those assertions. So beyond then the narrative content, the conformance artifacts that goes into part of that validation process, these are all part of what goes into the implementation guide. So the profiles, the operation, search parameters, and terminology-based conformance artifacts are all defined. Again, not all of them. Some implementation guides have more or less of these things, but typically you're going to find predominantly profiles or those structure definitions. As Graham indicated in his talk this morning, what is a profile but a set of rules and constraints? So data structures that tell us how we want to extend or constrain from the base specification. We can change cardinalities, we can invoke different constraints and invariants, we can actually apply different terminology bindings as well too. Also part of an implementation guide are operations. So I think of bulk data as an example. We have the $export operation. And so there's a custom operation beyond the base FHIR specification where we define the parameters, both input and output. And so because it's well defined, we can then test that. Search parameters above and beyond the base specification. So if you want to add more search parameters for your use in whatever domain you're in, you would do that as well. And terminology, again, we can do terminology bindings, and we're talking there more to the value set code systems. But there are other pieces as well, concept maps, naming systems. Generally, though, we're thinking more in terms of the code systems and value sets that we would use. So once we have all these components in our implementation guide, we want to validate based on those conformance artifacts. And so validation, and again, I'm talking about the validation engine here, validating a resource leverages those profiles primarily to check for structure, make sure that all the content is described correctly and is there within the resource. So nothing extra is present or structurally things match up to what we want. Cardinality, our min-max rules, if you will, to make sure we have at least one or we're allowed more than one. Value domains, again, this is going to be checking that the values conform to the rules for each element, whether that's within a value set or a constrained set of values, if you will. Code bindings is where we actually take those different elements that are of type, code, coding, and codable concept within the specification and bind those to a particular value set and say, this code or code within a coding codable concept can only be from this particular set of known values. And then the invariants are the additional logical expressions using the FHIR path language that get applied. So basically, if we want to do conditional things like, element A must exist if element B has value Y, type of thing. So we can build those invariants using FHIR path expressions. And all these things go into the profiles, the structure definitions that go into the implementation guide. And all that's going to get fed into the validation engine. So we use a FHIR validation engine, whether it's the Java RI or .NET implementations that the community maintains. If you want to roll your own, that's fine too, but generally speaking, probably stick with the ones that are out there and available. And again, supported by a FHIR test engine. So we have to have a mechanism or a means to invoke the validation engine through our FHIR test engine when we're executing our test definitions. Now, in terms of FHIR implementation guides, I'm obviously don't have a lot of time here in terms of trying to explain how you put one together. There's a lot of existing documentation out there that will help you with that. But in terms of publishing implementation guides, once you have your implementation guide ready to be published, there's a couple different ways of doing that. So from a publication perspective, the simplifier.net FHIR registry from FHIR some examples there would be from Canadian e-referral to our NICTIS MidMai program and so forth. The other publication tool that I'm more familiar with is the actual IG publisher that comes with the FHIR specification. It's actually maintained as a separate build outside the FHIR specification now. And if you're looking for documentation on that, the HL7 Confluence site has plenty of information on that. Lots of examples if you go to the FHIR registry, so registry.phir.org. Some examples there's an immunization decision support forecast implementation guide, which is actually what I'm going to be using in my upcoming demo here. Vinci here in the US, US core, think of the Netherlands core, various implementation guides, that are maintained and can be produced through the IG publisher tool. Additionally, a new kid on the block, Trifolia, although has been around for a little while now. So this is another platform that can also produce implementation guides. So this is from the Lantana organization, trifolia.lantanagroup.com if you're interested in that. So as an example of what these implementation guides might look like, NICTIS with MidMai, here you have an example of in Simplifier as a registry repository of those conformance artifacts. You could go to the appropriate Simplifier project for the NICTIS implementation guide, and you can actually examine those artifacts, and you can actually download the validation package that you would use within a FHIR validation engine. The actual implementation guide narrative is maintained in a separate site. And again, that's just up to the individual organization that's maintaining it. Another example would be that immunization decision support forecast that I mentioned. So here, this is part of the HL7 registry. This is currently under ballot, currently under development as well, too. So here, the representation of that implementation guide, once it's built and published, looks a little bit more like the FHIR specification. Okay. So here we are, made it to our first demo. So bear with me here, live demos are always fun, but I'm going to actually bring up, I have the FHIR IG publisher already up and running in the background here. So this is the GUI interface for that IG publisher. And so you would launch this as a Java application from a Java jar, and then you get this nice little GUI interface. The idea here is that you would need to choose, and I've already got the folder specified here, but you're looking for the control file, which in this case is our ig.ini file, and we're going to open that up. Now, so this implementation guide contents now actually has been updated to follow the latest template versions that we have from HL7 for their implementation guides. And so this is actually going to be leveraging some of the FHIR shorthand or FISH under the covers in order to build a lot of these things. But all I have to do is click on execute. and it'll start running on its way. So it's going to use Sushi, which is a Node.js thing that you have to download. Again, all of that's going to be specified in the documentation on the Confluence site. So you can see that running now in the background, and that's actually going to run for a little bit. And when this is done, it will actually produce locally on my machine the HTML content as well as all those conformance artifacts that we would need for that implementation guide. So again, that's going to take a little bit to run, so I'm going to let that kind of trundle along in the background here. We can come back and check on it. But the focus that we want from this publication process is, for our purposes, the validation package. So this is going to be the zip archive. So basically, it's in a package format. So basically, it just means the zip archive is a tar zip ball for the technical term. So basically, a TGZ format, if you will, as opposed to a zip format. But the idea is that the validation package is going to contain all the conformance artifacts that we need to feed to our validation engine, so that we can validate resource instances so that they conform or not conform, if we get error messages back. So actually, let me go double check on that, and we can see, okay. All right, it looks like, and of course, live demos are always fun because, things don't always go the way you plan. Let's see. There's a FHIR publisher, and it looks like we had exported sushi could not be run. Oh, wait a minute. Let's see. Yeah, it's going to be. All right. Well, ultimately, this is going to result in a validation package, which I've already pre-run, so we can actually take a look at that. So I'm actually going to shut this down in favor of using my pre-existing validation package. But the resulting HTML content is going to be looking exactly like you see here from the actual FHIR registry site. And so you can see here we have a table of contents, artifact summary, and so forth. So operation definitions, profiles, value sets, code systems, and lots of examples here on how to use this particular implementation guide. So one of the key aspects of this that we'll be talking about is using that validation package. Let me get back to the slideshow here, and I'll show you how that's going to work in just a little bit. So first and foremost, once we have an implementation guide, we do want to do testing, and some of those implementation guides can be fed into a certification program as well, too. So we want to take the published implementation guide, whether that's on a website or via PDF documents, but we want to make sure that it's published because we want to inform everybody of who's going to be using it. We want to be able to examine that narrative, human readable information with formatted text, pictures, and attachments that explain how to implement those specific use cases. Again, read carefully. We want to provide conformance artifacts for validation for data contents, and that's going to be that validation package that I was mentioning. So let's actually take the immunization decision forecast implementation guide, and there are use cases defined within there. And so what I'm showing you here is just an excerpt from that, where I've highlighted in this particular use case, what is it that we're trying to accomplish with this implementation guide? So we want to cover the exchange of data between two different systems, a system seeking patient-evaluated history and forecast information for immunizations, obviously, and a clinical decision support engine capable of providing that forecast. So currently today, this layer is not standardized, and so this is a FHIR implementation guide to create that standard interface layer between the initiating system and the CDS engine. Well, lots of things that we can have within there as well. So documentation-wise, what is our focus for this particular use case? And so the focus is this green area. So in scope, right, for this particular project is the request for data via FHIR request with a return of the immunization forecast, also in FHIR format. The other ends of the equation are going to be the CDS engine that's going to actually produce that content, and then the system at the front end that's going to be making that request and hopefully doing something meaningful with it. So also in the implementation guide is the definition of that operation. So that operation here is the IMMDS-forecast, so $ in front of that because this is an extended operation in the FHIR specification. So we have various parameters input. You can see there's an assessment date, some patient information, and 0 or more immunizations that have been administered. And then we have an evaluation optional, because note the cardinality is 0 to star, and a recommendation, which would be our immunization recommendation. So just to kind of show you that here, if I go into, the artifact summary, here is the operation definition. And so that's just exactly what I'm showing you before. The idea here is that the information being sent in, now for patient, which is kind of interesting, is that the patient, we do actually have a profile on it. So there's an IMMDS patient. And the thing that we're doing here is we're mandating that you have to have birth date. So we've actually changed birth date in this case. And you notice it's actually derived from the US core patient profile. So if we look at the snapshot, we can see there's the rest of the columns and so forth, but we are requiring the birth date because that's a required piece of information that we need for the forecasting to work properly. So when we think about building out a test definition, how are we going to test that a system is doing this correctly? So we have happy path or positive testing. So we want to do the immunization forecast okay flow, if you will. So we want to make sure things are, you send in a good payload, we get a good payload back. But we also want to do negative testing. So we're also looking for appropriate use of expressing when a failure has occurred. So it's kind of interesting. In this case, what we're doing is we're testing that the system is returning a failure condition, and we're going to pass the test if you send back the right failure condition. So the assertion here is to look for, the correct error messages or responses, if you will. And that takes us to our next demonstration, which is where in our Touchstone platform, I've actually built out the test script or test scripts that do this immunization decision support forecast. My wildfire FHIR server actually supports this operation. I've been working with the team that's been doing this implementation guide. So this provides us with a nice little example of how we might do this. So if I go to Touchstone, and so this is, I'm just going to sign in. Hang on a second. I'm going to minimize my display here a little bit so I can see what I'm doing. There we go. So I'm going to sign in. And we have a demo account for the purposes of showing off things here in the tool. So we have a whole, other training and so forth on Touchstone if you are interested. But the idea here is that I've built out some test scripts for the use of DevDays here, and these are based on FHIR R4. The ones in particular that I want to show you are these IMMDS forecast test scripts. And so the test script here, and again, this is just a resource within FHIR. So the test script is a first-class resource type with all the wonderful definitions that you can go take a look at. But the idea is that I have this defined already, and I'm going to be sending a request and expecting back an OK response. And the syntax of the payload, both request and response, will be in JSON format, which is why I've indicated that here. I also have one for XML if we want to go that route as well too. So let's actually go take a look at the execution here. So I've got my Wildfire 4.1 or R4 server as my destination, and it's going to be sending along parameters that has a payload for a patient with appropriate information, basically gender, date of birth, to de-identify the patient. We don't want to send along, full demographics in this case, and then any immunizations that might have been sent. In this case, we're not sending anything. Basically, it's just going to send the patient, and we're going to say, he hasn't had any immunizations yet. So we'll do an execute on this, and we'll wait for it to refresh, and we can see that we've actually executed and we have success. The thing to note here is that we have success with a W. So this has passed with warnings. So if we drill down into the actual test executions results, we can see there were 2 tests that were executed here. So we're looking for no assessment date and then one that did have an assessment date, because the assessment date was an optional parameter. So we'll send it in one test and we'll neglect to send it in another. So if I click on this and expand, and this is just the Touchstone interface that's going on here, we can drill down into the results, see what the payload was. So this was a fixture that we sent in, predefined with patient information, with gender, date of birth. And then, got my little thing in the way here, there we go. And then if we look at the body of the payload coming back in the response, we can see another parameters that was returned with our recommendation. We didn't get an evaluation in this case, that's again optional, but the recommendation is an immunization recommendation with all kinds of recommended, vaccinations and so forth, all codified and everything. And so what we're doing is we're testing the content here. We're making sure we get the correct response, we get the right content type headers, confirm that the resource type is parameters. And then this assert right here is the interesting one. This is the one that's going to invoke the validation engine. So the FHIR validation engine comes back with an interesting message. I get a warning back. Well, the warning is interesting. It says the structure definition reference, and note the reference here, for our immunization decision support patient profile could not be resolved. And that's interesting because, well, if I don't have that profile available to the validation engine, I can't really do full evaluation of the contents of what's coming back in the payload. So the validation engine is actually kind of nice. It's just saying, well, I didn't have the profile that you expected me to have, so I can't really validate. I'll give you a warning, but not much else. So that's, okay, but it's not really doing everything that I need it to do. So as an example of what we're trying to do here, that validation package, when you publish that implementation guide, we have a mechanism here in Touchstone where we have a number of validators or validation engine instances. And in this case, for FHIR 401, we have our base FHIR 401 validator. And these are all the validation packages from various IGs. Notice a lot of Vinci here as well. But I don't see the immunization decision support validation package. Well, I can simply upload that. So as I said, I had created this earlier, and so I can go back and locate it here, and we'll open that up. So now this is my TGZ, my package from that implementation guide, and I'm just going to upload it to my validator. So I'm going to include this now in the set of validation packages that I have deployed to my validator or validation engine instance. And you can actually see it's still doing an upload here. So we don't want to run any tests against this validator until it has finished uploading. We'll hit refresh here and we can see it's now complete. So if I drill down into this, I can actually see here's all the different components or pieces from that validation package that it's pulled out and made available to the validation engine. So now I can go back and let's actually rerun that same test. I'll create test setup just to go through the execute process again, and we'll let it run. And so it'll be interesting to see what happens this time. Now I happen to know that I'm still going to get some validation errors, and that was intentional because I wanted to show you that now that we actually have that profile on that patient, look what we get back. So now instead of warnings, I'm getting errors appearing. And these errors are because it's actually validating against that profile. So you can see now I'm seeing, oh, I had a minimum required of 1 for my identifier system, but I didn't find any. So it's complaining about that. You may ask, well, why did I get a warning if I have a bunch of errors? Well, the actual assert definition has a warning only true set on it, which just allows me to continue processing as we go along here so we can see things. So, that's just a nice quick demonstration now of how I can leverage the validation engine along with the validation package within a testing environment like Touchstone. So There is actual negative testing I could do as well. So just to kind of finish that out, let's go back over here. So here is the failure condition. So in this particular case, I'm going to be sending bad data. And so the, you might expect the test to fail, but actually the test is succeeding because my server is actually sending back the correct error condition that I'm checking for, because I forgot to send along a required piece of information. And so there's a preconditioned fail response that's returning. So basically, I'm just doing a response code greater than 399, just 400, 500, and so forth. And in this case, I'm getting an operation outcome returned as opposed to an actual parameter. So the payload here of the operation is an operation outcome. And you can see this is where you can get more information about what the problem was. And so this is complaining that we were expecting a patient gender, but it wasn't present. And so this is how you can examine those results and get more information. So with Touchstone, we have a lot of capabilities that allow us to handle testing and certification. And so other features of Touchstone, which I don't have time to go over here, but we can do program level support with organization groups. So if you have multiple organizations that are all within the same program, security and privacy settings for your test definitions. There's a FHIR sandbox, which is where I was actually running from, where you can upload your own test definitions or test scripts and make those publicly available or private to yourself. There is a remote API, RESTful API with Touchstone, so you could remote launch test executions and monitor them. Integration with continuous build environments, for example, like Jenkins or Travis. We do have a separate IDE where, based on Eclipse, where we can do TestScript development and direct upload to Touchstone. We have worked with the FHIR lead team, so we do have integration with simplifier projects as well, too. We have a number of wildfire test servers, and as you've seen, Java validation engines incorporated as services within the testing environment. As an example of program level testing, the Vinci use cases, we have a number of Vinci scripts out there. So if I go back to Touchstone, if I go to test definitions, we're actually going to see there's a Vinci sandbox here, and Vinci has a bunch of things here, various use cases that they've been working through. So some of these, if you've been doing anything with Vinci, may look somewhat familiar. To date, we've got about 20 different active use cases that have been identified. We have various reference implementations available. The MITRE Corporation has provided some. There's a Logica sandbox. And again, Aegis Wildfire can be used in some of those cases as well, too. In collaboration with MITRE, a couple of years ago, we published a FHIR testing validation paper. So please go check that out if you're curious about more information. And as I demonstrated within Touchstone, I do have some additional test scripts that you can play around with. So if you are interested and want to go out to Touchstone and play around with those, please feel free to do so. We have different things for testing capabilities, basic operations, workflow, using those basic operations, different ways of invoking the validation engine, and of course the demonstration test scripts that I displayed here with the forecast operation. So let's see, come over here. And so basically my contact information here during DevDays should be in the speakers gallery or as a participant in the Whova environment. You can reach me at richard.ettema@aegis.net. My Twitter handle is Technoman. That's actually my family superhero name, which is why I'm called that. So if you're curious, that's where that came from. And basically, if you want to learn more about FHIR implementation guides, the HL7 FHIR spec obviously has plenty of information on that resource type. HL7 Confluence, there's a whole site dedicated to FHIR designers, and under that, there's plenty of information about how you can install the IG publisher tool directly on your environment like I have. You'll need to read through those instructions carefully. With the new FHIR shorthand that's available now, there's some shorthand stuff that you have to follow and to make sure you have the sushi package installed correctly. And of course, lots of information on Touchstone if you're interested about our testing platform. So that is the conclusion of my presentation. So I'm going to turn over to the Q&A here and see what we have. So let's see. The title suggests to me that the FHIR IG itself is being validated, but I believe it's conformance testing of resource. Yes. So yeah, even though the presentation, the inference here is that your implementation guide contains all those conformance testing artifacts. And that's what you're going to be using, especially in the validation engine. But more so is that narrative context, those use cases. So as you look through and you want to come up with testing scenarios, even beyond just the validation engine, those are important aspects as well, too, that you want to incorporate into your test definitions. The second question I have is the validation package loaded on the destination FHIR server for validation, or does Touchstone have the logic to validate using the package? Well, from a Touchstone perspective, as I illustrated, we have those validators or validation engine instances. And so when I upload the validation package, I'm putting it into the environment for that validation engine. FHIR servers can also incorporate validation logic into their implementation. So in the FHIR specification, there's a $validate operation, which is what your FHIR servers would implement. And so if you're Java-based or .NET-based, you could probably take that code and incorporate that into your FHIR server. Okay. Any other questions or comments at this point? I think I have a couple minutes here for anything else that might come along. All right. Anything else that you'd like me to demonstrate? I could go back into Touchstone and show a few more things if you're interested. I'm not seeing anything else appear in the questions. So with that, I guess I will conclude. So thank you for your attendance. You can contact me again through these channels. So I thank you for your attendance and participation.